Good morning all. Today we will learn about linear and multilinear regression models. So regression and classification are part of supervised learning approaches. So supervised learning approaches are those learning approaches where you already have some prior information in terms of classes or labels or features. So they are referred to as supervised learning. So primarily, first we will begin with the regression approach, then we will proceed to classification. So let me start with linear regression. So in regression, we have three categories of regression approaches. First one is a linear regression, then followed by multiple linear regression, then logistic regression. So linear regression is a type of supervised learning algorithm approach where you mainly use to predict continuous numerical values. It is linear approach to modeling the relationship between a dependent variable and one or more independent variables. So basically in linear regression models, you will try to fit the data to a line. So linear here mainly refers to line and the regression refers to the relation that we try to determine between a dependent variable and the independent variable. So on a very high level, if I have to say, linear regression mainly tells about the relation between the dependent and independent variables with the help of a straight line. So this straight line of regression is fitted among the data to predict the new data points based on the existing data. So what is expected or predicted? Um, what is the expected or predicted value of dependent variable for a given independent variable is what we are trying to find through linear regression. For example, if you want to find what will be the sales volume of jackets that are usually sold in winters. So will the sales of jackets increase during winters? So if you want to do a feature prediction, then in those kind of problems we usually apply regression. So let's take an example of a linear regression problem here. So there are two problems that are been provided here. The first problem talks about consider the following set of points. So there are a set of points that have been given, and then you are asked to find the least square regression line for the given data points. And the second question, the second part of the question is you also have to plot the given points and the regression line on axis. The second problem is about future prediction of the sales of a company for a set of years that have been given in the table. So years 2005 to 2009 and sales data is also been provided. So first part asks us to find the least square regression line considering the gradient slope or the slope gradient slope equation y equal to ax plus b, where we are trying to find the slope and the intercepts here. So use the least squares regression line as a model to estimate the sales of the company in 2012. So an year which is not been provided here in the table, you are asked to find what will be the sales of that year going to be. So it is a future prediction based on the available data. Now let's try to understand the linear regression for the problem 1. So in problem 1, we can see that x and y values are being given and then you are asked to fit the data into the regression line. So x is the values of x are being listed here. We take the x mean value of x and mean value of y, and then we do a dot product of x and y. So dot product of x into y, and similarly, and then after that we square the x value. So sum of x square, and then we apply to the equation, the straight line equation, that is y equal to mx plus c, where m is equal to n times of summation xy minus summation of x into summation of y divided by n times of summation x square minus summation x whole square. So where c are the intercept and m is the slope, so c can be taken as 1 by n summation of y minus a times of summation x. So substituting the values, we get n is equal to 3. Substituting the values, we get the value n is equal to 3 because there are 3 data points that have been given to you, and once we substitute the numbers provided in the data set into these two equations, we end up getting these two values. So 23 by 38 and the other one is 5 by 19, and then we plot them on the graph. So what we are trying to understand here is what is how is x dependent on y, in by what terms. So if you actually draw one coordinate here connecting this dot with this dot, you end up getting what is called as a residual value. Okay, so that is how we determine the connection between the dependent and the independent variables. Now let's understand the second problem where x with years and sales has been given. In order to find the future value, we formulate this data set into this equation, into this expression, that is time. Say the time that we are trying to predict can be taken as x minus 2005, because um, from 2005 our data has been given, but we are asked to predict a future year, mainly 2012, which has not been given in the data set. So we just presume this time in the future, the year in the future, and what is its value going to be as x minus 2005. So the time series values are represented from 0 to 4 because there are 5 data points here. So y values are given already. So we do the dot product of t times of y, and then we apply t square, and then we substitute them into the same equation that we have applied earlier. That is, m is equal to n of summation xy minus summation x into summation y by n into summation of x square minus summation x square, where c is equal to 1 by n summation of y minus a times of summation x. So once we substitute this into the values into the m and c equations, we get to get the future value for 2012. So as t is equal to x minus 2005. So 2012 is what we are supposed to find. So 2012 minus 2005, that is 7 years. So the estimated sales in 2012 are likely to be the final value that we got here. So we have to substitute the slope and the intercept. So 8.4 into 7 times plus 11.6. So we end up getting $70.4 million. So that is the likely target, or the likely revenue, likely sales that are going to be probably occurring if the same trend continues in the sales of the company, right? So that is how we predict the future value from the given data points. Now let's understand the next concept, that is multiple linear regression. So multiple linear regression can be used for checking relationship and between dependent and independent variables. The only difference between linear and multiple linear regression is that we have more number of parameters here to consider. So the strength of relationship with one dependent variable and more than one independent variable. So for example, if you take how salary is calculated on the basis of the number of years of experience, number of certifications, or what the education qualifications of the employee. Okay, so all these also have to be taken into account when considering the salary of an employee. So not just that the experience of the employee and his age. So it is a multi-factor dependent problem. So where you cannot confine the problem to just one single independent variable. Right? So dependent variables value is given. Um, so the dependent variables value is given by the independent variable values. So the expected salary most likely will depend on the number of years of experience along with the qualifications of the employee. So in problems like this, we have to consider more than one criteria, more than one independent variables as a criteria or the factor before we determine what factors are contributing to the salary of an employee. Now let's proceed to the next type of regression, that is called the logistic regression. This is a statistical method that is used for building machine learning models where dependent variable is dichotomous in nature. So logistic regression is also otherwise called as binomial models, because most of the cases the logistic regression takes a dichotomous nature, that is either binary with 0 or 1 or true or false, male or female. So there is a dichotomy that is been represented in if the data is showing this kind of dichotomous representation, it is used. So in those kind of scenarios, the logistic regression is more suitable, because the relationship between one dependent variable and one or more independent variables can be drawn, and the independent variables can be nominal, ordinal, or interval type data. So logistic regression is also otherwise called a sigmoid function, because the representation of the logistic function, the representation of logistic function appears like a sigmoid curve, and the value also lies between 0 and 1. Okay. So the example of logistic function can be used to find the probability of a vehicle breakdown, depending on how many years it has been used, how many years or how many months since it has been serviced lost. Okay, lost to serviced. So problems like that can be considered for logistic regression. So primarily, what is the difference between linear and logistic regression? So linear regression mainly looks at non-dichotomous nature of data, where you might consider more than one, either one dependent variable or more than one independent variables. Whereas in the case of logistic regression, we usually have problems where there is some kind of a dichotomous nature. So where one particular independent variable can have subcategories. For example, income level. If you say high income, low income, median income, okay, gender. So all these, if your data set is consisting of these kind of dichotomous nature of data, then it is more likely that you should consider logistic regression than compared to linear and multilinear regressions. Okay, so for a customer service data, the proportion of customers who would recommend the service for a sample size of n is equal to 250. So let's say if there is a sample size of 250 customers, and the number of customers who responded yes was something around 210. So this indicates that the proportion of customers who actually liked the service was close to around 84%. So so the proportion of customers who would not recommend the service would likely be, if you subtract 1 minus 0.84, so it's something around 16%. Right. So this is trivial, that we can, by looking at the proportion of numbers itself, we can say that majority of the customers are happy with the service offered. But we want to understand this in terms of applying the odds ratio. So by applying the odds ratio, so we can say that roughly around 5 out of every one customer has actually rated it to be positive. So when we apply this data to the logistic regression model, that is log of p by 1 minus p, that is equal to beta naught plus beta 1, where beta 1 is yes, is equal to 1 if it is yes, and otherwise it is 0. So log of 5.25, when we apply this p by 1 minus p, turns out to be 5.25. So log of 5.25 is 1.658, and log of the remaining 0.6 is turns out to be 0.1905. So if you substitute them into this expression beta naught plus beta 1, So we end up getting what is called as so we end up getting what is called as a 3.316. So this is the estimate of slope. What would which would also give us a log of odds, that is minus 1.658 plus this slope estimate times. So that will give you um, uh, e power 3.316. So that is roughly around 27.55. So what we can conclude from this is, from the obtained odds ratio, the response for yes would increase by a factor of 27.55. Okay. Response for yes would increase roughly by a factor of 27.55. So by what factor? Uh, so by what proportion of customers who would not recommend the service offered by the department? So it is most likely that there will be 27.55% of customers who um, who would not be recommending the service offered by the department. So this is how we apply the logistic regression based on the data that is being provided to us. Similarly, let's take another problem. The sample proportion of women using Instagram is given as 61.8%, and the same proportion for men is 43.98%. Compute the logistic regression model to determine the effect of women and men using on the usage of Instagram. So we have the proportion of men and women. Now we want to see who is actually using Instagram as more than compared to the other. So we again apply the odds ratio. We compute the odds ratio for women, that is 0.6108 divided by 3842. If you subtract 1 minus this, so that's the odds ratio for men is going to be 0.7850. So considering gender, women to be 1 and men as 0, now again apply beta naught plus beta 1 and I'll substitute them in the log value. So we get 1.5694 to 0.7850. So the slope estimate turns out to be 0.6926, because if you substitute 0.4507 to minus of minus 0.2419. So we fit this into the logistic regression model and we get what is called as 1.9. So roughly around 2% of so from the odds ratio, the usage of Instagram by women is almost twice, because it's 1.9, almost twice the usage of men. Okay, so this is how we apply the logistic regression. So with this, I will stop this. So with this, we come to the end of the lecture on regression problems.